Hey guys, this is Mr. Bennett, and this is video 6-3. We've got a bunch of stuff to talk about in this video. We're going to talk about dissociation, electrolytes, strong and weak acids and bases. Seems like a lot, but it's actually going to go by pretty well, and or pretty fast. I think they fit together pretty well. So the first idea or concept that we need to talk about is this idea of dissociation. So what does dissociation really mean? Well, dissociation means to split or break apart. Okay, so that's what that concept is. And what we're talking about is the splitting or breaking apart of ionic compounds. Ionic means of ions. So if we put that all together, it's the process of an ionic compound, something like salt, breaking into its smaller ion parts, meaning a cation or positive ion and an anion or negative ion. So to give you an example, if we talk about salt, salt is made up of two elements, sodium and chlorine. Okay, and this is what we call its formula unit. It's simply a way of showing what the ratio is in the formula of this ionic compound. So for salt, table salt, it's 1 sodium for every 1 chlorine. Now if we take this salt and we put it in water, water will actually separate the two ions, the cation and the anion. Okay, and split them up so we can actually see their ions, we can see their charge. Well, we can't really see them, but they do get separated so that their charge is there. It's visible, they're no longer stuck together as an ionic compound. So if we're going to dissociate these, we need to figure out what their charge is going to be. So in the case of sodium, it's a group 1 metal, okay, which means it has 1 valence electron, and the easiest way, as we've talked about in the past, for an element that has 1 valence electron to get to its octet is simply just to lose 1 electron. Remember, you never lose or gain more than 3 electrons. So in this case, he only has 1 valence electron, so you might as well lose it. Okay. The other option is to gain 7, but again, you never lose or gain more than 3. So if sodium is going to lose an electron, okay, if you think back, if it were neutral, the number of protons would equal the number of electrons. But in this case, we're losing an electron, so this number here has gone down, which means that the number of protons is now greater than the number of electrons. If that's the case, that means we have more positives than negatives, which means that our overall charge of sodium is going to be positive. But how much of a positive charge? Meaning, is it positive 1? Is it positive 2? Is it positive 3? Well, you lost 1 electron. So that means that you lost 1 negative charge, which means that sodium now has a charge of positive 1. Okay. Now let's talk about the second element, chlorine. Now down here, this was kind of a long way of figuring it out. If you remember what we talked about in class, we said that all metals form positive charges. They're to the left of the periodic table. They lose electrons to get back to the previous energy level, so they form positive ions or cations. Nonmetals, on the other hand, like chlorine, they're on the right side of the periodic table, and the best way for them to get to their octet is to gain electrons. So that means that chlorine is going to have a negative charge because it's gaining an electron. Electrons have a negative charge. But the question is, how negative? Well, chlorine has a valence of 7. So to get to its octet, the easiest thing to do is to gain 1 electron. Okay, since we only gained 1 electron, that means that our charge only was changed by 1, which means it has a charge of -1. So we have sodium ion here. Remember, in terms of naming, metals are always just named after themselves. So this is sodium, and then we call it a sodium ion. Nonmetals, on the other hand, you take the beginning of their name, so in this case chlor, and then you add an IDE ending. So this is chloride. Hence, what we call normal table salt, the scientific name for that is sodium chloride. Final thing to point out here is, notice we have a positive 1 cation, we have a negative 1 anion. So if we go back here to the original formula unit, we didn't have any charge here. That's because it has a net charge of 0, meaning it's neither positive nor negative, because the cation is equal but opposite in charge to the anion. So +1 versus -1. When we combine those, they cancel each other out, and the formula unit is neutral. Okay, last thing I want to point out about dissociation is that when we do something like this, we take salt and we dissolve it in water, that's a homogeneous mixture, right? Same throughout. Salt at the top, salt at the bottom. Okay, if you were to taste it, it would taste salty at the top, it would taste salty at the bottom. And when we have homogeneous mixtures like this that are all in one phase, meaning you look at it and all you see is just the water, you don't even see the salt because it's completely dissolved, that's what we call a solution. It's a homogeneous mixture with just one phase, meaning you can only see one part, even though there's multiple substances there.